to Climate Change in Developing Countries, Lesson 5, Vulnerability to Climate Change in Cambodia.
Hello, everyone. Cambodia is highly vulnerable to the impacts of climate change as a poor agrarian country, which, relying on agriculture of natural rainfall and the annual flooding, include recession of the Mekong River and the Tonle Sap Lake, a major sector of the national economy. Therefore, agriculture is particularly sensitive to potential impact in local climate and monsoon regimes. Data from the past 5 years indicate that more than 70% of rice production loss in Cambodia was primarily due to flooding, while drought was responsible for about 20% of the losses.
A study conducted by the Cambodian Ministry of Environment in 2001 suggests that by 2100, rainfall in Cambodia would increase by 3 to 35% from the current condition, while temperature increase would be in the range of 1.3 to 2.5 degrees Celsius. These conditions may result in the increased occurrence of extreme climate events.
Over the last decade, Cambodia has experienced social, economic, and environmental impacts caused by irregular, severe, and more frequent floods, droughts, and windstorms under changed climate condition.
Case study indicated that the sea level rise will severely affect the 435-kilometer-long coastline, large parts of the Mekong River floodplain, and the Tonle Sap ecosystem, which is the heart of Cambodia's economy, culture, and environment. The study indicates that a sea level increase of 1 meter would inundate many coastal areas of Cambodia, specifically the province of Koh Kong. In Koh Kong City, a total area of approximately 44 square kilometers would be permanently flooded, the mangrove forest area to be submerged, and about 56% of the settlement area would also be flooded.
Vulnerability to climate change represents susceptibility of a system to harm due to exposure to a perturbation or stress. When a system fails to perform normally under a certain perturbation or stress, such system is already vulnerable. If it is being exposed to such perturbation or stress more often and no change in capacity to adapt to change, the system may become more vulnerable. If it has good adaptive capacity, the system will be able to cope with such changes, and its susceptibility level may decrease, or it may become less vulnerable. Thus, vulnerability is by a range of social, economic, and environmental factors, which the ability to cope with changing climate conditions. The most vulnerable areas need to be identified in order to prioritize action to protect populations and ecosystems. From this course, you can explain assessment of vulnerability to climate change in Cambodia, key factors of exposure, sensitivity, and adaptive capacity of exposure, sensitivity, adaptive capacity, climate change in Cambodia by RCP scenarios, and Cambodia National Adaptation Plan. So, should we begin the course? 1. Assessment of vulnerability to climate change in Cambodia. The figure shows the vulnerability mapping of climate change in Southeast Asia and Cambodia, show the vulnerable areas by region and country standards, respectively. It was found that Cambodia is one of the most vulnerable countries in the region. These provinces, districts, falling in the 4th quartile, were considered the vulnerable areas and further classified as mildly vulnerable, moderately vulnerable, or highly vulnerable. We used 2 different ways of ranking the areas. First, across the whole of Southeast Asia, and second, within each of the selected countries. This was done simply to rank priority areas for adaptation interventions by different users of this mapping information. The vulnerability mapping assessment, which was carried out for each of the 19 provinces of Cambodia, found that 7 provinces in Cambodia belonged to the top 50 most vulnerable regions in Southeast Asia, out of the 590 regions that were assessed. The Cambodian provinces' vulnerability can be qualified mainly to the low adaptive capacity of their inhabitants. This is not considering the fact that Cambodia is among the least developed countries in the region. The Development of Vulnerability Index of Cambodia based on socioeconomic infrastructure conditions and population data at commune level. The value of socioeconomic index of the communes in Cambodia range from 0.29 to 0.94. In 2006, communes with SEI of less than 0.5 are only for Phao Phet, Sla Kram, and Krek, and being considered as communes with best socioeconomic condition. Most of the communes located far from the Tonle Sap and Mekong River have SEI of more than 0.8, while the ones near the Tonle Sap and Mekong River have SEI of between 0.5 and 0.8. In the period between 2006 and 2008, there is slight improvement in the socioeconomic condition, particularly in communes located near the Mekong River, was shown in figure. The infrastructure index of communes in Cambodia is quite homogeneous and poor. Most of the IFI of the communes are more than 0.8, except in a few communes such as Dang Khao, Prek Pra, and Tuek Tla. However, in general, there is also slight improvement of infrastructure condition in Cambodia between 2006 and 2008, indicated by the decreasing number of commune with IFI of more than 0.86. Population index of the communes is also quite homogeneous. Higher population index are found in the communes surrounding the Tonle Sap. One of the communes near the Mekong River has PDI equal to 1, i.e. Trang Tuek of Pre Veng Province. This means that this commune has the highest population density and dependence ratio. Commune with high PDI will have high level of exposure to climate hazards as many people with high dependency living in this commune. Combination of the three indices resulted in the vulnerability index that has been grouped into 6 categories. From 2006 to 2008, number of communes with category of very vulnerable has decreased slightly. They change into vulnerable or to less vulnerable communes. 2. Key factors of exposure, sensitivity, and adaptive capacity. Climate change will affect many sectors and groups in society, but different sectors and groups will be affected differently. Differences between regions and sectors in society which determine the relative importance of such direct effects of climate change. More intense rainfall in some regions may harm nobody. In other regions, it could lead to devastating floods. Extratropical storms can kill tens of thousands of people in South Asia. In the United States, they lead to thousands of millions of dollars of loss and damage. Increased heat, stress, can be minor inconvenience to young people. To the elderly, it can be fatal. Cambodia is among the countries most at risk to the impacts of climate change on the Cambodian people, and key economic sectors are likely to become increasingly significant. Cambodia ranks 13th in the Global Climate Risk Index from 1995 to 2015, and 8th in the World Risk Index 2016. In 2014, Standard & Poor's ranked Cambodia's economy as the most vulnerable to the effects of climate change worldwide. Furthermore, the Notre Dame Global Adaptation Index assigns a high vulnerability score and low readiness score.
The geographical incidence of extreme weather events, such as floods, varies. While floods affect lowlands areas, the geographical distribution of droughts is widespread. Storms occur more frequently between August and November, with the highest frequency in October.
Vulnerability assessment is a step that requires thorough preparation and, ideally, involvement in all relevant stakeholders. According to IPCC, vulnerability is a function of the character, magnitude, and rate of climate variation to which a system is exposed, its sensitivity, and adaptive capacity. Exposure is defined as the degree of climate stress to which a system of interest is exposed. These can be either present or future changes in climate patterns. Sensitivity is, according to IPCC, the degree to which a system is affected by or responsive to climate stimuli. Adaptive capacity refers to the capability of a system to cope with consequences of or to take advantage of climate change. Based on vulnerability assessment, climate change and its impacts are assessed through the interrelationship, three components of exposure, sensitivity, and adaptive capacity. The key terms are explained by the Intergovernmental Panel on Climate Change as follows. Exposure refers to the nature and degree to which a system is exposed to significant climate variations. Sensitivity means the degree to which a system is affected, either adversely or beneficially, by climate-related stimuli. Adaptive capacity implies dynamic and influenced by economic and natural resources, social networks, entitlements, institutions and governance, human resources, and technology. Vulnerability is defined as the degree to which a system is susceptible to and unable to cope with adverse effects of climate change, including climate variability and extremes. Understanding the exposure and sensitivity of climate change and their interaction leads to the identification of the potential impacts. The potential impacts and adaptive capacity determine vulnerability. In Cambodia, agriculture, water resource, forestry, human health, and coastal zones are among the sectors identified as the most vulnerable to the impacts of climate change. According to the Climate Risk and Adaptation Country Profile prepared by the World Bank Group in 2011, since 1960, the average annual temperature in Cambodia has increased by 0.8 degrees Celsius. Furthermore, the frequency of warm days and nights has dramatically increased, while cold days and nights have decreased significantly. The future trend indicates that temperatures across the country are projected to rise by 0.7 to 2.7 degrees Celsius by 2060 and 1.4 to 4.3 degrees Celsius by 2090. While the mean annual rainfall trend is uncertain and is likely to vary between different geographical areas, an overall increase in rainfall is likely to occur during the monsoon season. The vulnerability assessment indicated that 17.2% of Cambodia's communes in 2014, which were highly vulnerable, and over 31.5% were moderately vulnerable to multiple climate change hazards. For 5 different climate hazards, the frequency of droughts, floods, and cyclones for about 20 years, physical exposure to landslides and inundation zones of a 5-meter sea level rise. The sensitivity map assessment was encompassing both human and ecological factors, was derived using the weighted averages of the standardized values of population density and protected area. Thailand, Cambodia, and Laos, PDR, have relatively more protected areas compared to other countries in the region. The Tung Nhai Narasan Wildlife Sanctuary in eastern Thailand, the Nakhai Nam 10 National Biodiversity Conservation Park of Laos, PDR, and the Mundulkuri Protected Forest of Cambodia. 3. Prospects of climate change in Cambodia by RCP scenarios. Cambodia's initial national communication of the UNFCCC includes the first attempt to assess the country's future climate using 2 general circulation models. The GCM models used in this analysis were developed for use in Japan and Australia, which are very different geographical regions. However, at the time of the assessment, there was an absence of more suitable models. The analysis showed that the deviation of the GCM models from the observed rainfall data was very significant. The projections conducted are in changes in the average temperatures and rainfall, with the caution that there was significant deviation between observed rainfall data and GCM model output. The following projections were made for Cambodia. Mean annual temperatures could increase between 0.3 to 0.6 degrees Celsius by 2025 and 1.6 to 2 degrees Celsius by 2100. Mean annual rainfall could increase between 3% to 35% by year 2100, with the magnitude of change varying with time and location. Lowland areas would have higher increase in rainfall than highlands. Cambodia has developed climate change scenarios and its impact on sectors. The climate change scenarios was developed using Model for the Assessment of Greenhouse Gas Induced Climate Change, a regional climate scenario generator.
a program which links emission scenarios with global and regional climate change. All the impact models used in the INC are statistical-based impact models, mostly regression approach.
In the second national communication, Cambodia has adopted Regional Climate Model in combination with a number of GCM models run by Climate Risk Assessment Division, Center for Global Environmental Research, National Institute for Environmental Studies with resolution of 100 by 100 kilometers. To cope with scarcity of historical climate data in evaluating the impact of current climate variability on sectors, long historical climate data has been reconstructed using PRE-CIS for whole Cambodia. A dynamic-based impact model was adopted for agriculture sector. Cambodia is among a group of 52 developing countries for which Oxford University has completed climate change country profiles. The profiles are based on data collected from national weather stations through the World Climate Research Program and available on the Global Historical Climatology Network. Cambodia's profile includes average time series of observed data over the period 1960 to 2006 and projected future climate under the IPCC emission scenarios. The respective storylines of the scenarios are differentiated world, market-oriented world, and convergent world. The climate models consist of a subset of 15 from the 22 used by the IPCC in its fourth assessment report. Maps depict projected changes for decade-long time slices in 2030, 2060, and 2090 on a 2.5 by 2.5 degrees grid. By using all data downscaled by PRE-CIS, Regional Climate Model for Mekong River Basin over the land area were averaged 30 years period of record started from 1960 to 2099. Based on the result of rescaling temperature data of all grids from PRE-CIS. It was found that the rate of mean monthly temperature increase ranged from 0.013 degrees Celsius to 0.036 degrees Celsius per year, depending on the location. The rate of temperature increase is high in low-altitude areas such as in the central and in the northeast of Cambodia, and low in the high-altitude areas, such as in southwest region. The projection of maximum temperature shows a clear increasing trend in mean temperature data, ranged from 32.7 degrees Celsius to 37.1 degrees Celsius from 2008 to 2099 by using scenario A2. However, the projection of maximum temperature is also increasing. Trend in mean temperature ranged from 32.7 degrees Celsius to 35.9 degrees Celsius from 2008 to 2099 by using scenario B2. The projection of minimum temperature shows a clear increasing trend in mean temperature data ranged from 23.5 degrees Celsius to 27.7 degrees Celsius from 2008 to 2099 by using scenario A2. However, the projection of minimum temperature is also increasing trend in mean temperature ranged from 23.5 degrees Celsius to 26.3 degrees Celsius from 2008 to 2099 by using scenario B2. By using all data downscaled by PRE-CIS Regional Climate Model for Mekong River Basin over the land area were averaged 10 years period of record, started from 1960 to 2099. Rapid increase in rainfall is expected to occur after 2010 and will be continually increasing in year 2050 and slightly decreasing from 2070 to 2099. Shows in figure. The result of analysis shows a clear increasing trend in average rainfall data. By using all data downscaled by PRE-CIS Regional Climate Model for both scenarios A2 and B2, were projected annual precipitation from 2008 to 2099 of PRE-CIS SRESA2. by increasing in rainfall is expected to occur after 2008 and will be continually increasing in year 2050 and year 2074. And the projected annual precipitation from 2008 to 2099 of PRE, CIS, SRES B2 shows in figure. 4. Cambodia National Adaptation Plan. UNDP, UN Environment, and GIZ helped to identify entry points in order to develop the Cambodia's NAP process was institutionalized in 2014, and adaptation is progressively taking a more prominent role in the government's policy agenda. A comprehensive stock-taking report was compiled to that end, in line with the UNFCCC, NAP, and LEG technical guidelines, and further strategic intervention areas, climate change adaptation processes in Cambodia were analyzed. The goal of the NAP process builds on the objectives set by the National Strategic Development Plan 2014 to 2018 and the Cambodia Climate Change Strategy Plan 2014 to 2023 and focuses on strengthening and better integrating ongoing processes. There are 3 phases for proposing the implementation as follows. Short-term actions are the preparatory work needed to establish a functioning NAP process and setting the framework for implementation and continuous learning. For example, setting up mechanisms for vulnerability assessments, creation of intersectoral coordination mechanisms, data systems collection, setup, and to start mobilizing resources for implementation of adaptation measures. Medium-term efforts are that implementation of the NAP process by using and building upon the structures and tools set up during the first phase by conducting vulnerability assessments, upscaling of adaptation pilot projects, and dissemination of results to stakeholders. Longer-term endeavors are implementation of NAP priorities, but with an emphasis on review and learning, as well as adjustment of established processes and arrangements. Some of the foreseen features of the longer-term efforts would be to mainstream adaptation into long-term development planning, budgeting, and monitoring systems, as well as to review and adjust the NAP process. The implementation plan for priority actions is required based on the NAP financing framework analysis and articulation of various financing dimensions. This, built on an analysis of financial demand and gaps from the existing Cambodia Climate Change Strategic Plan 2014 to 2023, sectoral climate change action plans, existing relevant documents and key interviews with line ministries, national stakeholder consultations, and an examination of the international climate finance landscape. The NAP framework is making both medium and long-term recommendations, as well as short-term suggestions for 40 priority climate change actions. These include, among others, to pursue sector-wide or programmatic approaches rather than small-sized projects, to strengthen project and budgeting capacities, to further develop a national repository on climate science knowledge development, to further strengthen sectoral coordination, to continue to mainstream climate proofing into ministries' budgets and integrate gender dimensions in climate responses. NAP process is the development of its implementation plan. Its design should incorporate concrete actions to trigger the implementation of NAP priorities in the short term, should facilitate potential synergies with other climate programs in the midterm, and should enhance the country's capacity to further plan and implement adaptation measures in the longer term. The development of an NAP requires an iterative process. A number of aspects need to be expanded to achieve a strong and complete NAP financing framework implementation plan: data gathering, assessments, further prioritization exercises, coordination efforts, and capacity building. The NCSD has led a planning exercise to present a first iteration of the NAP implementation plan in Cambodia by supported from GIZ. The process had 2 phases. 1. Identification of the set of 40 priority actions from CCAP for the NAP. 2. Implementation of short-term actions when possible. Further, its mid-long-term recommendations can nurture a process that could facilitate a more effective planning and implementation process in the future.
Summary. Let's review and summarize what we've learned so far. We learned about vulnerability to climate change in Cambodia. We will learn about international trend and resources regarding adaptation to climate change next time. Goodbye.